Hello friends, welcome to part 24 of the flexible packaging series. In this part we will explain rotogravure fingerprint symbols. This slide shows sample fingerprint layout. You can scan the QR code to explore what is fingerprinting. First, let's explore color bars and gray balance scales as shown in the picture. What the image shows, it contains horizontal color bars that gradually change from 0% that is white to 100% that is solid. Top 4 bars are pure CMYK primaries: cyan, M for magenta, Y for yellow, K for black. Next 4 bars are 2 color overprints. They are called secondary colors. M plus Y is red, cyan plus yellow is green, cyan plus magenta is blue, cyan plus magenta plus yellow becomes neutral gray, that is 3 color overprint. Bottom bar is 4 color overprint, that is C plus M plus Y plus K, that is full process black, that is rich black. Purpose in fingerprinting layout. It serves several quality control functions. First, tone reproduction. Each bar goes from 0% that is white no ink to 100% solid ink. This checks how smoothly tonal value reproduce and whether there are any sudden jumps, bending or dot can issues. Second, gray balance. The CMY bar, that is 3 color gray, is crucial. If the press is in balance, it should look neutral gray. Any shift too warm or too cool indicates imbalance in one or more inks. Point number 3, overprint check. Secondary colors red, green, blue verify how inks trap over each other. Poor overprint shows as muddy or weak colors. Point number 4, ink trapping and consistency. It confirms whether inks print cleanly on top of each other without excessive dot gain or poor trapping. Point number 5, process control reference. Operators can use these strips during fingerprinting to see if the press matches the expected CMYK color behavior. Now let's discuss colored spheres as shown in the picture. They represent solid ink colors and overprints rendered in a smooth 3D gradient ball shape. The purpose of colored spheres is to check smooth tonal transitions, highlight to shadow, balance and overprint color rendering. It helps identify issues like bending, streaking or uneven ink laydown. The colors shown are green, that is cyan plus yellow, red, magenta plus yellow, blue, cyan plus magenta and black. Gray tones CMY or CMYK overprints are also shown. Pure yellow, magenta, cyan process primaries are shown. Now let's discuss concentric rings as shown in the picture. They are printed in black and CMY. They are used to check for dot growth, uniformity and clarity at small sizes. Any distortion, that is uneven rings, breaks, shows press, engraving or ink flow problems. Rings and rosettes, starburst radial patterns are shown in the picture. The purpose is to detect slur, doubling and registration accuracy. If the star is not sharp at the center, there is slur or misregister. Tonal value patch set is shown in the picture. It is used for tone reproduction and gray balance control in rotogravure fingerprinting. What the image shows, it has rows of color patches arranged in steps from 0% to 100% tonal values. Top row is cyan 0% to 100%. Likewise, there are other rows and overprint rows. Each row is divided into discrete tonal patches in 2%, 5%, 10% to 100% instead of smooth gradient. This element checks tonal accuracy and dot gain at different percentage values. Point number 1, tone reproduction curve, that is TRC. Each step should match expected tone values. Deviations show dot gain or dot loss, that is 50% page printing as 60%. Point number 2, highlight and shadow control. 2%, 5%, 10% patches are highlight dots. Test if fine dots are held on press. 92%, 95%, 98% patches are shadow tones. Test if dark areas plug in or retain details. Point number 3, gray balance verification. CMYK row 3 color gray should appear neutral gray, and its shift indicates imbalance in one or more processings. Point number 4, overprint and trapping check. Magenta yellow, cyan magenta rows, that is secondary colors, verify clean and consistent overprints, no muddiness. Point number 5, process control. Operators and color technicians use this chart to create or compare with a tone reproduction curve, that is TRC, and adjust engraving or ink. Now let's discuss text reproduction quality. What the image shows, different font sizes of the word Hamburg fonts. It is a standard text word in typeface design and printing text because it contains a wide range of letter shapes. Text appears in both positive, that is light text on dark background, and reverse, dark text on light background. Font sizes shown from 1.5 point, 2 point, 3 point, 4 point. This element evaluates fine text reproduction and reverse text reproduction. It also evaluates edge definition and sharpness and contrast and legibility. Now let's discuss Linework reproduction and slur detection. The image shows two sets of vertical lines with different thickness from 0.1 to 0.75. Left block shows black lines on a gray or black background. Right block shows white lines on a black background. Purpose in fingerprinting layout. Point number 1, Linework reproduction. Very thin lines test the resolution limit of the press. Thicker lines check for edge sharpness and ink spread. Point number 2, positive versus reverse line clarity. Black lines on light background versus white or gray lines on dark background. Reverse line work is harder to hold cleanly. Highlights issue like filling in or poor ink transfer. Point number 3, slur and doubling detection. If lines look smeared, uneven or doubled, it indicates mechanical slur or vibration during printing. Point number 4, Dr. Blade and engraving accuracy. It tests how well fine engraved lines transfer ink and how clean the Dr. Blade wipes. Classic Starburst test elements are shown in the picture. 4 Starburst radial patterns, one in each process color, that is magenta, black, cyan and yellow, are shown. Each starburst has fine lines radiating outward from a central point. Purpose in fingerprinting layout. This test pattern is critical for point number 1, slur detection. At the starburst center, if the lines blur or smear in machine direction or cross direction, it indicates slur caused by press vibration or mechanical issues. Point number 2, doubling identification. If lines appear duplicated or ghosted, it means doubling, often from improper impression, cylinder issues or press instability. Point number 3, registration accuracy. When printed in multiple colors, misalignment shows up as colored halos around the starburst arms. It helps verify color to color register in fine details. Point number 4, resolution and sharpness check. The fine lines test how sharply the press can reproduce details from center outwards. Any filling in or loss of separation between lines shows resolution limits. The picture shows CMY gray balance ramp. The image represents a CMY cyan, magenta, yellow, gray balance tint ramp at different tonal values, like at 60%, 70%, 80%, 90% and 100%. Instead of using black, the image is built by overlapping cyan, magenta and yellow. This is typically used in press fingerprinting to evaluate tonal balance, trapping and neutral gray reproduction. In gravure printing, a fingerprint test is done to establish the press unique characteristics. This CMY ramp helps in point number 1, gray balance check. Proper balance of CMY inks should produce a net neutral gray. If the gray shifts towards red, green or blue, it indicates ink strength imbalance or engraving issues. Point number 2, tonal reproduction curve. It shows how tones build from 60% to 100%. Any deviation, lighter or darker, helps identify dot gain or dot loss, engraving depth variation or ink transfer efficiency. Point number 3, hue shift monitoring. In gravure, dot shapes and ink laydown can cause unwanted color shifts. These gray swatches help check if darker tones remain neutral or lean towards a color. Point number 4, cylinder and ink behavior. At higher densities 90 to 100%, problems like filling in, mottling or missing dots become visible. At mid-tones 60 to 80%, issues like cell uniformity, Dr. Blade setting or viscosity problems can be diagnosed. CMYK step wedge control targets are shown in the picture. The chart contains tint patches of cyan, magenta, yellow, black ranging from 1% to 100%. Each color is shown in a step wedge to evaluate tone buildup. At the top right, solid patches of CMYK and rosette star patterns for each color. This test chart is used during press fingerprinting to evaluate how a gravure press reproduces tones and solids. Key aspects include point number 1, tone reproduction curve. The 1 to 10% range helps check if very light dots are printing or lost, common in gravure due to shallow cells not transferring ink. The 90 to 100% range checks if high density tones are merging or filling in or maintaining definition. Point number 2, ink transfer and density control. Each steps 10%, 20%, 30% to 100% allows measurement with a densitometer or spectrophotometer. It shows how well ink transfer at different tonal level. Point number 3, gray balance evaluation. The combined CMY row helps check neutral gray reproduction. Any color shifts indicates incorrect ink strength, cylinder engraving or viscosity issues. Point number 4, solid ink density and hue. The solid patch 100% are measured to determine proper ink density. It ensures each process color is consistent and within industry standard tolerance. Point number 5, rosette star targets top right. These patterns help check for dot gain, misregistration, gear marks or cylinder irregularities. If edge blur or distort, it indicates mechanical or impression issues. Overprint and trapping test, CMY circle. The picture shows 3 overlapping solid circles of cyan, magenta and yellow. Where they overlap, they form secondary colors. Cyan plus magenta forms blue or violet. Magenta plus yellow forms red. Cyan plus yellow forms green. Where all 3 overlap are neutral gray. Purpose in fingerprinting layout. This element is used to verify ink trapping and overprint quality. Point number 1, overprint colors. Test if secondary colors red, green, blue appear clean and saturated. Poor ink transfer or contamination produces muddy, dull colors. Point number 2, gray balance check. The overlapping center CMY should appear neutral gray. A shift towards warm or cool indicates an imbalance in one or more inks. Point number 3, ink trapping. Ensures one ink layer properly accepts the next without rejection. Critical in rotogravure where ink thickness and drying affect trapping. 4th, registration accuracy. Misregistration is easy to detect. Overlap won't align properly, creating colored fringes. Now let's discuss color characterization target or ICC profiling in fingerprinting. The image shows hundreds of small color patches arranged in row and columns. The center area has neutral gray scales and gradations. Surrounding patches cover a wide gamut of CMYK and overprint colors. Side labeling indicates patch positions. It is labeled as GMG color chart V2, a standardized test form for color management. Purpose in fingerprinting layout. This chart is used for objective color measurement during fingerprinting. Point number 1, ICC profile creation and characterization. Each page has a non-CMYK value. By printing and then measuring with spectrophotometer, you capture how your press actually reproduces color. These measurements are used to build ICC profiles for accurate proof-to-press matching. Point number 2, tone and gray balance evaluation. Central neutral gray patches confirm whether gray bills from CMYK match target values. Any shift indicates ink balance issues. Point number 3. Ink trapping and overprints. Hundreds of combinations of 2, 3 and 4 color bills test how inks trap over one another. Point number 4. Color gamut mapping. The spread of colors shows the printing system's achievable gamut, useful for comparing one press substrate ink set against another. Point number 5. Process control and repeatability. Printing this chart repeatedly allows you to track press stability over time. Deviations in page color, delta is shift shows consistency or drift. Now let's discuss pictorial test element, that is image reproduction. You will see many such half-tone images on the fingerprinting layout. The image shows a portrait of a model surrounded by fruits, drinks and objects in bright yellow and oranges. Background is uniform yellow tone. Side panels are color swatches and gradients extracted from the image. Purpose in fingerprinting layout. This element is used for real-life image reproduction testing, which is the ultimate check of how well the press handles complex printing challenges. Point number 1. Skin tones. Human skin is very sensitive to color shifts. Any imbalance in CMYK or gray balance shows immediately in unnatural skin color. Point number 2. Neutral and saturated colors. The image has both highly saturated oranges, yellows and neutral tones, gray, brown shadows. This checks the press ability to handle vivid colors while keeping neutrals accurate. Point number 3. Highlight and shadow details. Bright highlights, glasses, fruit sign, light clothing test whether fine highlights dots are retained. Shadows, hairs, folds in clothing test whether shadows tone plug in or hold details. Point number 4. Gradients and background uniformity. The yellow background must appear smooth without bending or streaks, a test of tonal gradation. Point number 5. Memory colors. Colors we recognize instantly: skin, fruit, orange, juices. A fingerprint test ensures these memory colors print realistically across substrate. Color swatches, side panels provide reference colors values to compare with actual print output, used for densitometric and spectrophotometric evaluation. Now let's discuss FL23 rapid check control strip for color and density verification. This strip is very long, so here in the photograph we have shown only a part of the strip. Purpose in fingerprinting layout. This strip is a quick reference tool used to check essential printing parameters. Point number 1. Solid ink density. Each solid, cyan, magenta, yellow, black is measured with a densitometer or photospectrometer. It confirms ink strength is within target range. Point number 2. Overprint colors. Magenta yellow, cyan magenta, cyan yellow. It tests secondary colors red, blue and green. Shows how well inks trap on top of each other. Point number 3. Gray valence. Neutrality can be checked using overprint combinations and by comparing against standards. Point number 4, substrate influence. P patch is equal to paper white shows how the substrate affects overall color appearance. Point number 5, process control and verification. Used during fingerprinting to verify if the press matches FL23 reference standard. Widely used in ISO 12647-2 print process standardization. It helps create repeatability across proof, press and reprints. Let's discuss GMG Unified Wedge Tone and Gray Balance Control. The picture shows only the part of the GMG verified wedge strip. It is a sequence of color and neutral patches arranged in a strip. Labels include tone percentage 5, 25, 50, 75, 95 and 100. Purpose and fingerprinting layout. This wedge is designed for objective measurement with spectrophotometer and visual checks. Point number 1, tone value reproduction. Cyan and black patches at 5 to 95% allow measurement of dot gain. Critical for matching press behavior to FL23 standards. Point number 2, highlight and shadow control. 5% and 95% patches check whether highlights are holding and shadows are open. Point number 3, gray balance check. Neutral gray patches 25 to 75% test whether the press produces neutral gray without colored cast. Point number 4, solid ink density. 100% cyan, magenta, yellow and black used for measuring density and calorimetric values. Point number 5, standardization. This wedge is part of FOGRA certified workflows. It ensures proof to press consistency and enables repeatability. Scan the QR code on the left to explore a series on a complete guide to rotogravure printing machines. Fingerprinting symbols turn invisible print challenges into visible solutions. Thank you.